pp2020's paper, given that it's a cubic polynomial, it means the highest degree x to the power 3, and then it's divisible by x minus 1. When fx is divided by this one, the remainder is this one. Now, can we put x equals to 1 or equals to -1 and then saying that equals to this one? Actually, you can't, okay? Even it tell the information in this format, this one is not a linear equation. Here we need to use the division algorithm. Form the polynomial by yourself. So first, you know that f1 equals to 0, and then form the polynomial by the dividend, the quotient. You know the quotient should be in the highest degree should be 1. Why? Because when this times this, the highest one should be to the power 3. So here, the highest one will be 1. Okay? So it won't be the quadratic equation here, because when this times this, ax to the power 3. So here is power 3. If here is power 2, they times together will become power 4. Okay? Okay, so we let the unknown, the quotient here, plus the remainder, and then put in what we have found here. After you put in 1 here, here equals to 0. So you can find out kx plus a equals to k equals to -8. Okay, 5k. So b, now given that x plus 3 is a factor, when fx is divided by x, the remainder is 24. Someone claimed that all the roots are integers. Is it correct? Okay, so now we know that when we put x equals to -3, it should be equal to 0 because it's a factor. And now it is divided by x. Okay, what does it mean divided by x? Because usually it presents in this format, right? So when we divide by x, it actually means x plus 0. Okay, x plus 0. So it means that when you substitute x equals to 0, the remainder is 24. Okay, so this one is not obvious, but you need to find out. So the first line of part B is f put in 0, and then we have the remainder 24, and then you put here the formula we form ourselves here, and then we substitute x equals to 0. You will have -1 times b, and because here x equals to 0, so this term disappears, plus 8. Okay, so you calculate b equals to -16. And then when you find out the unknown b, you haven't found out a, right? So another information, f -3 is equals to 0 because it's the factor. Okay, so we put in 0. And then here we put in -3. You will find a because you already find b and you already find the k, right? So put in the number. Now we have the whole complete polynomial. We need to find the roots. And then the question already provides to us x plus 3 is a factor. So when we expand the polynomial into the format we're familiar with, from the highest degree to the lowest one, and you need to check whether this one is cubic polynomial. And for this polynomial, actually, we can take out the common factor first. Okay, after you take out the common factor and then do the long division, first you have x plus 3 as the factor. Remember in the question, it provides us that x minus 1 is another factor. So you know that when this one divided by x plus 3, we will have another quadratic equation. And this quadratic equation should be further factorized into two roots. So this polynomial here can find out 3 roots, which is -3, 1, and -2. And all of them are integers, so the claim is correct.